Welcome everyone, my name is Dario and today we're going to be talking about authentication and authorization in .NET. Why you should make your authentication in the middleware pipeline and authorization in your filters and not make authentication in your filters. In order to do that, we're going to first talk about middleware in ASP.NET Core. Let's take a look at that. Middlewares are components of the ASP.NET Core framework that will allow you to execute code in a pipeline way. This means that a piece of code is going to be executed, is going to give you the opportunity of execute a little bit of code, and then pass the responsibility of what's going to happen next to the next middleware, and so on and so on. Unless your middleware decides to stop executing and return back the control, it will go cascading all the way down until the endpoint or your final code is executed. This is where usually your logic lives, your business logic, your controllers, or your minimal API endpoints. For authentication, there are some built-in middlewares that ASP.NET Core provides, and they are placed as the last two middlewares that are executed before the middlewares that you can hook up. Ideally, you want your middleware to be executed after all of these, but there is nothing preventing you from placing middlewares in between these other ones. We're going to see how to do that later. If you see that there is authentication being done in filters, it's probably because they carry on some legacy way of working that was provided in ASP.NET Web API 2s. This is technology that Microsoft implemented a long time ago, and it's part of the .NET framework. Authentication in .NET framework was done by filters for API version 2. But now in .NET Core, there is no need for that because we have the concepts of middleware. So if you see authentication filters in ASP.NET Core, definitely that can be done better in middleware. And the question is why? Why do you want authentication to happen on middleware? And the reason is simple. Imagine that your application is where you live. If you leave the door open of your house, anyone can get into your house and can reach your living room, your bedroom, the place that you're staying, or your garden. And you don't want that. You want that the front door is closed, and when someone knocks on it, you allow them to get inside or not. That's why you want middleware to be placed to do authentication. This video is going to be focused on API key authentication, which is not out of the box built in .NET. So I created an example, which I provide the link to the GitHub repo in the comment sections, and you can play with it. So you want the door of your house to be closed, and that's where the middleware comes in place. You don't want people to be inside your house knocking your bedroom door or your bathroom door. That's where the filters are. Filters are already someone inside your house trying to dig and see what it can do. The less amount of time a potential attacker stays inside your code of your application living, the better it is for you, because there is less opportunity for them to find vulnerabilities. We are never exempt of vulnerabilities that are built in with any framework. It could be .NET Core, it could be PHP, it could be anything. Every microsecond, nanosecond that an attacker is executing your application, it's a potential risk for you. So the earlier you deny the entrance to someone, the better it is for you. Less resources are consumed and less opportunity for them to hijack your application. Because API keys authentication is not built in, we're going to now see an example on how middlewares work and how we implement API keys in middlewares. So as mentioned before, you can have middleware executing in all the different levels of your pipeline. When you have your web application, you usually use your app builder to say which middleware needs to be used. You see as a convention that in order to register a middleware execution, you will see the word use and something. This is saying that use the Swagger middleware, use the Swagger UI middleware. Here we are saying use the authentication middleware and after the authorization middleware. And at the end, map controllers that will execute the code. When we say use authentication, .NET Core is going to be expecting that we have registered some sort of a scheme that is going to handle the flow of the authentication. Same happens with authorization. So how do you do that? You tell .NET Core to handle authentication, registering different components in your service collection. I created this add API extension method for convenience, where I have registered everything that we need. The first thing to do is to tell .NET Core services to register authentication with a specific scheme. And a scheme is going to be looked up by the framework while executing the code to instantiate the classes that are going to be making all the challenges and verifications of our API key. So I have defined an API scheme called API key, and I'm telling to .NET Framework, to .NET Core, to use in our authentication middleware the default scheme to be the API key. Then we need to tell that the scheme that is being added has a specific handler, and this handler is going to be used against this scheme. Then we have to register the components that are going to play with the authorization part of the application. I'm going to use policy-based authorization. You can use a different one. In order to register policies, I am registering a policy that is for read and another policy that is for write. This is a simple API, and all I want is to give clients endpoints that they can consume by reading or send something by writing. At the end, because I need this, I need a place where to get API keys and see if they exist. I am going to add also a claims provider that is going to generate an identity, and 2 more implementations are required, and that's authorization middleware result handler and authorization handler. We will see them while we execute. What I'm going to do now is I'm going to go to my scheme handler where I have my first breakpoint, and I'm going to debug the application. So here we have the application running, and what I'm going to do is I'm going to get a get on my books endpoint, and we will see that my scheme handler is called, and the method that is being called is authenticate async. Here is where we're gonna check if the request is not required to be authenticated. You don't need to do this. This is basically to show you what you can do. Basically, you can check if the endpoint is health, then don't perform any sort of authentication. But it's not. It's the booked endpoint. So let's try to find the API key. The API key is not present, so we're gonna fail the request. Oh, what happened? Well, it seems like the authorization middleware is executed, and yes, that's what happened. By default, .NET will execute the authentication middleware and the authorization middleware, trying to find someone that has been authenticated. Because we are not authenticated, this is gonna fail, and this permission requirement is not gonna succeed. If the authentication fails, .NET provides a way of returning a challenge to the client. This is useful in cases where the client is a web-based application and you can redirect people or the user to a login page. In case of an API key, usually you're gonna provide API keys for B2B, where there is a backend application consuming your data. So there is no need to implement a challenge, but you can do that here. Here you can implement code that will, for example, return a status code 302 to redirect the web, the browser to another page. We can see here that the return code is for 1, means unauthorized. Now let's authorize with one of the keys that we have and see what happens. We have two keys, one that is read-write and one that is read-only. So I'm gonna make a request with my read-write, and I'm gonna execute. I'm just gonna pass this. I can see that my context has a customer. This has been authenticated with this API key. Perfect. Now let's move forward, and we can see that now we have books. Let's try now to create a book. I'm gonna just make it simple. It seems like succeed. Yes, 201 has been created. Now let's query again on the books. And we can see that now we have 2 books and the new one that we just created. Let's try now to create another book with the other key. The other key is exactly the same, but finishes with a 1. Now let's try to create a book. We can see that we have a key. Let's try to find the key. The key is present, so let's move forward. And let's move forward. And we can see that now the code is 403. This means that the user is authenticated. This means we know the API key, but the code 403 is returned when the user that is authenticated doesn't have the permission to perform that action. So we have to understand 2 different concepts. One is the user is someone that we know. It's a valid API key, it's in our system, and it's okay. The other concept, which is authorization, is that that user, that API key, can perform the action that it's trying to do. It could be get a list of items, create, update. All of those are different actions, and those are the ones that we link to authorization. Because this API key has read-only access, the API key has permissions that are only read-only, are here. The permission is read and read-write. That's why they cannot create books, but they can read books. This is really useful when you have an API and you want some users to do modify data and some users to read data, or you want to give to one user 2 different keys to have different controls of the actions that they do. If they leak if for some reason they leak the right API key, they still can access their data with the read key. Okay, let's go now and understand how the authorization works. Let's make a request to write. This is the handler. This is authentication. We have covered this already. We are now on the permission authorization handler. Permission authorization, I implemented this with filters. You can check that the books controller has a permission read authorized attribute, a permission read authorized attribute to get, and a permission write authorized attribute to create. So what you can see here is that the permission write has a policy that is write, and the permission read has the policy that is set to read. So if we go to the handler, once the user is created, and the user is created in the context, the user has a set of claims because the user is of type of a claims identity. What we're gonna search is that in the user there is at least one claim that has to be with the permission that we're looking for. Do we have the permission claim that we're looking for? No. The requirement that is instantiated for this action is the right. That's what we're looking for, right? Because the claim is not present, we do not succeed this requirement and the flow continues. So that is as simple, and there is no other magic, and there is nothing else to learn from how .NET handles this. Now, as we mentioned, authentication is a middleware and authorization is another middleware. Authentication may fail, but .NET is going to execute the next part of it. And you wonder, why is that? Well, it's built like that, but you can make it work in a different way. What we're going to do is we're going to do something between our authentication and an authorization that is going to be a short circuit. This is a middleware that we created in order to prevent the execution to go from the authentication middleware to go to the authorization. Basically, this middleware, once it's invoked, it will check that the user has an identity and is authenticated. And if it's authenticated, it will continue to the authorization, and if not, it's not to go to authorization and it's going to return 401 immediately. This way, we avoid to get into the next middleware and we short circuit immediately, which is what we want. So I'm going to debug now. And if I am not authenticated, this short circuit, I'm going to log out. I'm going to get the books. We are on the short circuit middleware. We see that we have a claims identity, but it's not authenticated. So it's not going to go to the authorization middleware and immediately returns 401. Now, let's authenticate this. And we see that it's authenticated. So we go to the next part, and the next part is going to the authorization middleware. That, my friends, is authentication and authorization implemented in the right way in .NET. I hope that you enjoyed this video. I ask you to please subscribe and to share this with the rest of your team to implement authentication correctly in .NET.